now. We're good.
Okay, cool. All right. And hey, everybody who's on the phone here. This is the first, I think, hybrid in meeting for me, at least from a presentation standpoint. Yeah, recording. Okay, cool. We're good. Actually, I'll close that just to make sure we get all the screen. I can't. Never mind.
Canada.
I can't even get to it. No, never mind. All right. All good. Yeah. So good evening. Let's see if this thing works too. Maybe. It was. There we go. All right. Yeah. Hey, everybody. I'm Chris Seferlis. So I'm a client technology lead here at Microsoft. I've been here for the past 3 years. Spent a little time at a Microsoft partner, Pragmatic Works, for a couple of years, and prior to that, was a CIO for a couple of seafood companies here in the Northeast. Grew up in IT, so a lot of the stuff that I do now as part of my job is to try to understand this stuff at a high level from a strategic standpoint, to be able to help align the Microsoft technology stack across the stack with their goals and objectives to meet their business needs. And so I still play with some of this stuff for fun. And it's been a while, but occasionally I'll throw a video blog out there. And I do like to engage the various communities and stuff, which is a fun part of my job. I got some other stuff here. You guys can all check that out later. Real quick, shameless plug. I am writing a book. Got approached from PACT last year about cognitive services. So it actually kind of made it easy to do this presentation, because a lot of what we're working on here with the cognitive vision, computer vision, custom vision, all kinds of vision is based on what I wrote for a chapter in the book. The book is largely based on a fictional seafood company, given my experience and the way that AI using cognitive services can essentially help them be more efficient, optimize operations, improve customer service experience and all that. And it should be out sometime October, November timeframe, assuming we meet the deadlines, which we've not done a great job of so far. So if you are interested online or here in the room, if you're interested, let me know. We are looking for reviewers. You get a free book, you get a free year subscription to PACT, which is all their books online. If you guys are familiar with like the O'Reilly subscription and stuff, I'm going to trip over that. But if you're familiar with that, you get a year subscription, so you can, get all their content and stuff like that. We do ask for, basically reviews of the book and somebody to actually read it. Plug done. All right. So computer vision, the topic of the night. So what is it? According to Wikipedia, it's the study of building artificial systems that process, perceive, and reason about visual data. What does that mean? It means that we're using a computer to see what a human sees, ideally, right? And then, essentially being able to extrapolate what it is that we're seeing, describe it, and then be able to do more with it, which we'll get into here. And so basically, when we look at how a lot of these, somewhat public computer vision models look like, an example would be this, right? We use reCAPTCHAs all the time. We use CAPTCHAs, reCAPTCHAs, right? And in essence, you go and you pick those images. Those are building a machine learning model to be able to capture the images. So in this case, we're looking for a stop sign. You can see it's a somewhat blurry stop sign. And if we don't hit it in time, then our car is going to crash. Obviously, it's somewhat of a joke on the computer vision that we're seeing day to day. But every time you see a CAPTCHA or a reCAPTCHA, what you're doing is actually building and feeding into that machine learning model to be able to capture, what's happening in those images. So simply some basic versions, right? We've got image classification. So in this case, it's an airplane, right? But if you notice, there's a whole bunch more in that picture. You've got people, you've got the plane, you've got another airplane in the background, right? We can go so far to say that, if this were an airplane use case, we've got the, what do they call that thing? The gateway, or I forget what they call it. No, it's the thing that extends out. There's a name for it. I can't remember. Anyway, so, you've got other elements here that go beyond what the actual focus of the image is, right? So we look at the object detection, what's happening in there, right? And then finally, we want to look at the segmentation of the image to say, well, where is this stuff, right? Because as we start looking at some more business-like use cases, we want to know through a quality process where something is located within a grid, right? And because of the image segmentation aspects of computer vision, it gives us that ability to be able to pinpoint exactly where that is, okay? So as this has evolved, right, we basically have something very familiar, I would say. Yeah, right. So we've got self-driving cars, and it looks like the normal driving experience that we're all used to when we drive in a car on a day-to-day basis. However, what's really happening is we're seeing all of these other things, right? We're identifying them so we know what to do with them, right? So if we see a stop sign, a traffic light coming up, we need to be able to interpret what we're seeing to be able to stop or continue the same rate of speed or begin to slow down. We see objects in the road. We're following the lines to follow our lanes, right? There's a whole bunch of things going on inside this image, and the CPU, GPU inside the vehicle needs to be able to know how to respond to these certain elements. And so ultimately, where we started with this was, believe it or not, back in the 50s, late 50s. Scientists said, well, can we mimic the way that a human sees? I said, geez, how do we do this? What's the best way to do it? And they said, well, a cat's brain is eerily similar to a human brain. And so if we take this electrode and put it in the cat's brain, and we show it different images, we start to actually see how they're processing those images. And so what we wind up starting to see is the various elements of the image as they're looking at it. And you start to get the ability to add those features of that image to what is actually happening in front of you. And so when we think about an image, right, from a computer standpoint, it's a flat image and it's a bunch of pixels, right? And so when we want to identify what's happening in an image, we run a filter of sorts over that image, and you basically span the whole image up and down. And as you do that, it starts to create an image map of what's happening. And it's signified in number value, just like we're used to, for everything with computers. Everything ultimately turns into ones and zeros, right? And so essentially, we're assigning areas of that image into an algorithm, and then we build our matching based on that. And that's sort of the foundation of the image recognition process, right? So when we look at how they're processed, first things first, we're going to take an image and we're going to convert it to grayscale, right? And so basically we're going to lessen the complexity of the image by making it only 2 colors. Theoretically, only 2 colors, less colors, right? And so this allows us to then give us the ability to, basically not pay attention to, the blues and the reds and all that. And we can just focus on, our grayscale images. And then as we equalize it, we're going to increase the contrast of the image to be able to then, again, take away some of the detail, when we think about Captain America's shield and his chest and all that stuff, right? We're going to lessen that so that we can, get a sense of what's happening. Because when you think about an image and the pixels within an image, they're, depending on the size of the image and how much it's pixelated, there could be millions of pixels within an image. And so a lot of that can be noise, right? And so what we're doing is we're actually simplifying what's appearing in the image, because to a human, we want to see this nice and sharp and clear, including the color one, right? But to a computer, rather than having to process all those pixels and make it super complicated, we want to strip out some of that complexity. So we increase the contrast, and then we remove that noise, right? So this is our contrast increased image. Now we've basically taken it and we've said, okay, and now you can tell this is a lot blurrier than the original image we were looking at by pulling out all the stuff that we didn't need in that image, right? And again, this all works toward that process of being able to build a baseline for what we're trying to recognize. So after we remove the noise, right, then we're going to look at the edges, right? And a lot of this stuff is how, again, when we go back to the cat example, the cat was seeing the edges of an image. They were seeing, you know, the arcs. They were seeing the different contrast elements, the shaded areas and things like that. And so now we're going to detect the edges of the image so that we've got an outline of what it is that we're looking at, right? And at a simplified level of how this gets built up, and ultimately we classify an image, is you take the original image, you do this spanning, like I mentioned, in your pixelated areas, you run it through your various filters, if you will, and then you identify the parts that are happening within that image, and then essentially from there, you create a classification, okay? And so after you've built this original model, and there's a bunch of them, ImageNet and a couple other ones, I'll name here in a few. But essentially, you have that baseline image classification model that you're working against. And so on the right there, it's basically running it through here. It sees this is a cat, so it says, yes, this is a cat, okay? Now, there are obviously some challenges with this, right? This is a cat who is sitting there prone, relaxed, right? You can tell by its face that it's a cat, somewhat by the body that it's a cat, right? But if it were backwards, as a human, we might be able to interpret that as a cat. As a computer, kind of depends how good your model is. Have you trained it on the rear end of the cat, right? So, and these are all the types of things that we have to consider when we start talking about custom vision. And so, again, we have this base classification that we've come up with, right? And we've got a data set that we're working against. We process that image, we classify based on what that is, and then we interpret it to say, what is the image that we're looking at, okay? Trying to keep this somewhat high level. There's a whole bunch of, convolutional neural networks and all that kind of stuff going on in the background there. But again, trying to keep it high level so that we know what we're looking at when I start looking at the customvision.ai portal that we offer as a way to build your own custom models, okay? So now, when we start thinking about the computer vision aspect of things and the Azure tool that we've created, we basically saw that we've got a massively growing adoption of computer vision as it goes to a whole bunch of different industries. You can see the largest here are automotive and some of the consumer industries, and they, massive gap growth. And anybody want to say what happened from basically 2015 through the current? I mean, what have we seen a massive explosion of in the last 5 to 10 years?
Self-driving cars.
Nope.
IoT and cloud.
IoT and cloud.
Self-driving cars.
Okay. I was looking for more why we're seeing this growth.
Oh, IoT.
More
Pictures. Everyone is taking pictures.
How do we process this?
Compute.
A lot more GPUs, right? A lot more CPUs, GPUs, a lot faster CPUs, GPUs, FPGAs, right? And with cloud, right? So Bill, to your answer, yeah, IoT, because we're able to capture that information better now, right? But we're able to process it a lot better because of the GPU capability and the advances that we've had with GPUs and FPGAs, right? And so now we're seeing a lot of these companies want to be able to take advantage of this for a whole bunch of different ways of building out solutions based on what they can do with computer vision. So in essence, when we start talking about some of the existing networks, right? So AlexNet, ResNet, these are some of the base models that were created, way back. I mean, some of these go back to like the 60s, 70s, and 80s when we didn't have enough CPU, GPU, FPGAs to be able to process these images and process these massive swaths of data. And so, in essence, we learn based on what we've already created and then enhance based on our requirements. Okay. So on the base model approach, you have the ability to take an existing model that sits in cognitive services that Microsoft already wrote for you. And this is true of all the cognitive services, right? You've got a base model that Microsoft is providing that you can use against, you can use for your solution to be able to do things like, speech to text, text to speech, language, decision, all these different categories that we have in cognitive services. And many of them, not all, but many of them have the ability to build your own custom models using similar technology, knowing that some models are business domain specific, things like that, right? So we want to be able to give our users the ability to do their own thing. So in this case, when we build a custom model, which we'll go through in the portal here, we can start from a baseline and then build our own model to then be deployed within the service. Ultimately, in order to ensure that we've got a process by which we are constantly improving our model, there is a best practice standard, right? You capture your image, you transform it, you analyze it, and then you have your output, and then you're continually retraining that model to make it better and better and better, right? So if we want the rear end of the cat to be identified, then we need to train down the rear end of the cat to know that it's also a cat, right? So in essence, we've got now the tools to build it. We've got a baseline to work off if we want to, or we can build our own. When we get started with the tool, the recommendation is to use about 50 baseline images when you're building your model in order to have a good data set to work against. And that's per classification, if you will, on what you're building against. And so, again, I'll show the pre-canned example that we have, on the Microsoft Learning site. Some of the use cases that we're seeing in industry, workplace safety is a really big one, right? Where, we've got the ability to now be able to determine if somebody is wearing a hard hat, or if somebody falls on a production line or something like that, where there could be a safety issue, so that you can instantly react to a situation like that, shut down production so that nobody gets hurt, things like that, right? Retail floor tracking. We have a newer cognitive or computer vision service called spatial analysis, where in essence, you can see where people are in proximity in a location. So you think of a retail example, what are people gravitating toward, right? Do they really like a specific dress in a store, right? Does everybody go check out that dress because it's really pretty or whatever, right? And so it gives retailers the ability to somewhat understand what's happening within these locations to be able to then say, well, we need more dresses like that, or maybe it's the color or whatever, right? And then, there's a bunch of examples where we're doing this in real time, for a lot of customers. If you get a chance to go upstairs into the MTC, we've got a couple of examples where manufacturers and things like that are using some of this, again, for things like workplace safety, quality control, those types of things as well. Here's just some of the lists of the services. I want to highlight it. And then the full list is there. We do have some interesting things. I'm not sure if anybody saw the announcement that what we just recently announced, that we will no longer use our facial recognition software to identify things like expressions, race, gender, those types of things, right? In order to make sure that we're not discriminating and things like that. So we do have a facial recognition component in there, but it's it's a little bit in limbo where it is. We do have a statement on our website saying law enforcement can't use it and things like that. So, some interesting things to come there on the facial recognition side, because there are some really good practical uses for it. But then on the flip side, there are some really bad uses for it too. So, our video indexer service, it allows you to, capture different elements of a video, identify speakers and things like that. The computer vision has a bunch of stuff, standard things like OCR and those types of things. And then of course, the things we talked about, image classification, scenery description is pretty cool because you can give it a picture and it can describe the whole picture for you. And just some of those types of things. So there's somewhat of a list, and go check out the site to go from there. I thought it'd be good to share a reference architecture just so folks get a good sense of what this looks like as it's deployed. Because the example that I'll show uses the customvision.ai website, which is you can use it to build your model. You can use it to classify images. You can use it to label images, but it's not something that would be used in a normal production scenario to operationalize a computer vision use case. It's really meant for those tools, but then you basically export your model for consumption using an API. But so in a typical scenario here, you essentially bring your image in, you drop it into storage. You can use any number of things. They got an Azure function there. You could use Data Factory. You could use a whole slew of our different tools to pull it in there. It falls into a storage account, and then you've got a notification in the event grid that says, hey, we've got a new image. Again, this is just a sample reference architecture. There's a million ways to slice a cat, as they say, right? You can trigger an event, again, using a function app to pull in, and essentially, depending on what service you're looking to do, you would either use one of the canned models, one of the pre-built models that Microsoft, has won awards for and all that, or you can use your own custom vision model that you've created. And then from there, basically, you can post the results to a database should you want to. And then there are other downstream activities that you can do with it. But in essence, I think you get the picture here, right? Where depending on what you're doing with this image, there's a whole bunch of ways to do it. I don't know how we get out of this though. Gonna double check my reference architecture because I'm just stuck there at that point. All the arrows point back to it. Huh. That's kind of funny. Anyway, but yeah, so that's a general reference architecture where you can get a sense of how it would be used and how you'd use the service. So let's look at the port. All right. So I have a one example that's pre-built. Again, if you go to the Microsoft Learn site, this example, it'll walk you through it, how to build it and everything. For all intents and purposes, we'll just kind of go through what a basic project setup would look like. And then we can loop back and look at the existing project, right? So you're going to name your project, you're going to put a description, all that kind of stuff. You're going to determine where your resource is, where it's coming from. Essentially, you're defining your Azure Cognitive Service that is for the custom vision portion of this. So basically, the compute that is doing all of your model creation. In this case, the Artworks one, it was already built. That's on a standard tier. We do have a free tier. You can only process a certain amount of images, and you can only use certain classification and domain types. But there's a lot of options there to play around with that. You can also create your new resource here.
So you have to log in as you need to have an Azure principal ID or something like that to log in?
Yeah, you'd have to have an Azure account of some sort. You'd have to have contributor rights to be able to create some kind of resource.
When you log in, you just know you go to customvision.ai.
Yeah, I'll show you. I'll just show it. I'll just do a basic one. You can see what the portal looks like. It just gives you this login, right here, sign in, then sign in with your
This would
Azure
be your
account.
Azure account, okay.
So a few different things, right? So you've got project types, right? Where you're doing either a classification or an object detection, right? And depending on which one you pick here, it's going to determine, some of the downstream operations that you're looking at, right? So whether it's going to be multi-label or multi-class, or, which domains you're going to be able to choose, and so basically, when you think about the definitions there of object detection or classification is, are you building a model to create your own custom classification to then check images against? Or are you looking for what's happening within an image based on an existing model, right? The existing model that Microsoft has built. In our case, for the artwork example, we're going to use the classification piece. Now,
So
then you
what is the output of this? An ARM template?
say again?
What is the output of all of this? It's an ARM template which you deploy in your Azure account or?
No. So actually what it does is it allows you to publish a model, and I'll show that in a minute here. But it allows you to basically to publish that model to then be able to check images against that model.
No, my question is, I get it. In the sense you'll upload images and it'll do something, but what's the output? It'll create a model which can be operationalized using your Azure account?
Yes. Yep.
So it'll create some kind of ARM template which will go and.
It's not a template. No.
It's an API call.
Yeah, it's an API call. So basically the API call calls the cognitive service. So I've got my image that I want to test against my model, right? You say, hey, does this match my model? Is it a cat, right? And so I'm calling that API, sending that image to it,
Okay,
and it'll say yes or no.
all right.
Okay. And so when in the example that I use in the book, I'm testing lobster tails, right? And I'm saying, is a lobster tail good or bad, right? And there are certain elements of a lobster tail where I know whether it's good or bad, right? Is it missing any of the flippers, right? Does it have any cracks in it? Is it miscolored, right? Does it have a weird looking color to it? Are there pieces of shell missing? Things like that. And so when you do that detection, I've got that pre-trained model for good lobster tails and bad lobster tails, right? And so it returns back with a certain percentage of accuracy, whether or not it's a good or bad lobster tail, based on the image based on the model that I created, okay? Now, when we look at the classification types, right, is it a single tag within an image, or is it multiple tags within an image, right? So are we looking to classify multiple things? And this was tricky when building my lobster tail example, because it proved challenging to have multiple lobster tails within a single image to be able to say, yes, these are all good or these are all bad, right? Because that was really the only answer. Otherwise it would get confused and say, oh, So basically we wound up boiling it down to a single, that was kind of an unintended pun, to a single,
So how does it,
label.
like if you got like 7 lobster tails, just don't take it literally,
Mhm.
and say the third one is bad,
Mhm.
so it draws a triangle around the third one and says this one is bad?
Well, no, it's not that sophisticated of a system, to be honest with you.
Okay.
What we wound up having to do was isolate each of the tails to do our classification based off of that. You couldn't send it several images. Now, what I did find was that it handled noise very well. And what I mean by noise was, let's say we've got a nicely perfectly shaped lobster tail right in the middle, but then you've got 2 on the side that are a little obscured. Maybe you don't see the whole tail or something like that. Generally, it would take the one good image and classify based on that, right? In the example in the book, we use a single tail and a grid, right? And then basically process the identifier of the grid to be able to say, this tail in this grid is bad, pull it off, right? And then we've got a reinforcement learning system in the background where it says, is it a false positive? Where in this case, a positive would be a bad tail, right? So was it actually a good tail? So you give it that feedback to say, nope, this was a good tail, or yes, it's a bad tail. I know it's a little weird,
No, I
but,
think it's fine.
but you know what I'm saying, though, right? Yeah. So basically, we've got a ways to go on being able to handle sort of multiple testing and things like that within those images. So we had to isolate the tails individually. When we look at the domains, these are all based on your use case. So, the general A1, A2 are based on the size of your models, how many images you're throwing at it, what are you trying to do with it? I actually wound up using general A1, and actually I think you can. Oh yeah, no, you gotta go to the documentation site to specify what each of them are. We've given some, some general categories on what we see. Anything here that's compact is designed for deploying to a phone, right? Because basically, a lot of these examples are being used, for quality purposes and things like that with using a phone to scan for it, right?
The latency is too, you can't go in the cloud because the latency is very low for those kind of things, right?
It's partially that, but then it's also partially, you think about your phone, it's probably got like a 12 megapixel camera on it, right? And so it's sending a massive image up to the cloud to test against, right? So it's the size of the image and then how long it take to come back and get that. Whereas for the compact version, you can actually store that right on the phone within a database on the phone and do that.
So how does, from a pricing point of view, is it like when it's on the phone, it's like a little bit cheaper, but it's per API call, like the other?
Yeah, there's a few factors in there. It depends on the tier that you're using. It depends how many, how many transactions you're making, the size of the data that you're using. So it's got a few factors in there. But yeah, so I mean, you can basically build an app on the phone. So we've got an app called Seeing AI that's out there on the App Store. I think it's only on iOS. I don't think it's on Android. But it basically will do object recognition. Actually, I can demo it real quick. So it's just a regular iPhone app.
Short text.
Yeah, so let's see. Do any?
Create new project. Description, project description. Resource per. Stance. Project types.
So you get,
Data
so that's in
classification.
text.
Detection. Class person. 2 faces.
Right, so we're
0
detecting two
faces.
people.
2 faces. 0 faces.
There's barcode readers, there's currency readers, there's all kinds of things like that. This is more used to be for like an accessibility tool so that, people who are seeing impaired and things like that have a tool to be able to use it. But that's an example of sort of a compact model being deployed out to the phone, okay? And then, again, depending on what your use case is here, I think I used general A1 if I'm just going off memory. And that was just based on how much data I was expecting, from the images, how many images were going to be there. And that all kind of goes into how much processing time and how much processing power you need to build your model and then test against your model after the fact. So then we deploy, and in essence, then you start to upload. So if we go into the Artworks project here, you can see that I've got some images already loaded, and we've got some labels, right? We've got a label for a painting, tag. We've got a tag for painting. We've got a tag for an artist and 2 other artists. And so what we can do is we can, quickly train against what we've learned. You could do a quick, not train. You can quickly test against what our model is, right? And like I said, this is more for testing purposes. It's not really made for production purposes. We'll get into the production aspect of it here. And you can either upload a file or you can just put in a URL. So if I go in and I've already done a search here on Picasso paintings, and if I go and look at this painting and I grab and I grab the link. Let me copy the link. Go back. We copy the image. The image link. I have done this before. Paste it in there. So it's pretty sure it's Picasso, right? There's 99.9% sure it's a painting, right? It's 99.8% sure it's a Picasso. Name another artist besides the three listed. Let's test a different one.
Van Gogh?
Van Gogh. It's 2 words, right?
Yeah.
Use my handy Bing. Company guy here. UUGH. Yeah. Right, so if we look at Van Gogh, oh, this is a familiar one. Probably one of my wife's favorites. Check here. Again, really sure that it's a painting, right? Could be a Picasso. We've got a 6% chance it's a Picasso, right? And so basically, with our very, very rudimentary trained model, I mean, we're only talking about 19 images total that we've labeled here, right? We haven't given
how do
a
you label
massive
an
data
image?
set. What's that?
How do you label an image here?
I'll show you in a second. But, you know, when we're looking at, you know, a very, very small subset of images that we've built our model off, it's going to basically analyze those images, look at the various, you know, what would be strokes. It's kind of hard to pick up the actual brush strokes because we're not looking at an actual painting. You can't get the depth of it and stuff like that. And like a real art curator would know the difference based on some of those things. But based on a quick test, based on the image, it's like, hey, well, there's a chance that it's a Picasso, right? Yes, sir.
Can you upload a picture of a cat or not a painting to see what the model says?
Yeah, that's a good question because I wonder if it would still see it as a painting, you know?
Maybe a cat or the dog.
Yeah.
whatever.
Dog.
We'll use the front of the cat, not the,
There are 2 women on that, so you have to be
oh,
careful.
I don't want paintings though.
Yeah, and without painting, yeah, like a picture.
Oh, this guy's cute. Snookums. Is his name Snookums? I'm guessing it's gonna think it's a painting still.
Let's see. This is what I would like to see.
No?
Good?
Yeah. Yeah. So, yeah, that's a great test. I didn't even think of that. Thank you. He's got some messed up whiskers though. He looks like he's been up to no good. But yeah, so, you know, the point here is, right, we've got a very, very small model built, right? Like I said, the recommendation from Microsoft is 50 tags or 50 images for each tag, right? So as you get more and more accurate, you know, as you add more and more examples, it gives you the ability to get more and more accurate with your predictions. Now, one other thing too, there's a term called overfitting in machine learning, if you guys are familiar with that. And in essence, to avoid overfitting, you want to make sure that each of your tags is sort of built equally, right? So you wouldn't want 50 Picassos and then 5 of Pollock and Rembrandt, right? Because you're going to have issues where it's going to be swayed way too far in one direction. It won't work super efficiently. So just something to bear in mind as you're building out your model here. Now, we've got a couple of things we can do. So let's just download my cat image here. And you asked about tagging. So if we add a new image. There's my image. And then I can choose from one of the existing tags. Or I can actually just upload it. And here I can get a suggested tag. This feature is called the Smart Label. So what this allows you to do is upload a bunch of images and do its own labeling of these images to say, well, we think it's a Rembrandt, we think it's Picasso, we think it's a painting, whatever it is, based on our model as it exists. Or in this case, right, we would want to create our own tag. Call it a cat.
So what if I want to segment it, like I have objects in that picture?
You wanted to segment objects within that picture itself, you would actually use a different model for that. So remember when we were looking at building a new, you've got the ability to do object detection or classification. And then within classification, you've got the ability to do single label or multi-label. You would have to label the various areas within those specifically.
So I'm just trying to understand. So now once I do this labeling, it creates a model of my thing on Azure services, right?
Mhm.
So how would I go to the next step in which, okay, the model is created, how can I consume it? Right? I can either use Logic Apps or Azure function code. What is the next step here?
I'll show you in a second. Let's just see if this can detect that it's a cat. Now that's, oh, I didn't retrain this, actually. I've got to do a quick train before I do that. Because I didn't retrain it on the new label.
So just now it's running your Azure build as you're doing the training.
Doesn't like something.
Non-negative tag you need.
You need
And 5 images you need.
You need
Five.
5
Oh, right,
cats.
yeah, I need 5 cats. Yeah, okay, we're not gonna mess with that because that'll take too long. But I think you get the idea, right? So then you retrain, then you test against it again and go from there.
So does it tell you how much of your Azure bill is that you're doing?
Not in here. You'd have to go into the Azure portal and actually look at the service as it's doing the consumption. And by popping that up right now, I don't know what will pop up, so I don't want to go ahead and go down that road tonight. I do a lot of like testing and stuff in there, and there could be other stuff that I don't want you to see.
That's all right.
So, yes, sir.
So when you have, for example, your model in production and you would like to do this reinforcement learning.
Yeah.
So you can start to add new tags or fixing wrong tags.
Yep.
You need to retrain again, right?
Yes.
Okay.
So, and you can trigger that retraining via API call, or you can do it right here in this portal.
Yeah, but I'm guessing that, okay, you don't train every tag, you do the bunch of changes.
Yeah. And we actually had that discussion as we were building our example for the book again, right?
Yeah.
Where it was like, okay, go back to my lobster tail example. And let's just say over the course of a day, you've got, 50 tails that either are false positives or are positive positives, right? And you want to go in and retrain that. It's not efficient to retrain it after every single one, because what's happening is you're taking your model offline to retrain it. Now, I think there may be a will to leave the existing model in place while it's retraining. I think that requires a higher tier because it requires a whole separate set of compute to be able to process it, right? But in essence, the way we set it up was let's retrain it every night at midnight. So we get an image that comes in. It's a false positive that we want to retrain on, tagging it as a good tail because it was detected as a bad tail. We want to tag it as a good tail. So basically, you make we send it to a storage blob for reprocessing. It gets picked up by the training engine, essentially tagged appropriately, and then retrains the whole model.
Right. Clear. Other question that also is related to the training. I have been here discussion about the bias in the training set.
Yeah.
So any thought about that? Is covering the book as well?
That's
It
why the
is.
face vision, that's why the face vision is.
It's a touchy subject, right? It's a, so we have what we call the responsible AI framework. Are you familiar with that?
Yeah.
Yeah, so if you guys aren't familiar with it, we have, basically a guideline around how to appropriately build AI models, right? And then operationalize those AI models, right? And so a lot of it goes to, being public about what it is that you're building, right? Making the code available so that folks can see what you're building, right? What steps in documenting, like what steps did you take to remove bias and things like that, right? So it's a set of guidelines. Again, there's nobody forcing it. It's just a matter of trying to have, the right folks doing it, right? Ethical people that are building these, but there's no real enforcement at this point. Now, as a Microsoft employee, right? If I witness something, within a customer use case where I identify something that breaks the rules of that responsible AI checklist as I know it, I'm required to report it, to our legal to be able to say this is being inappropriately used. For instance, using for face detection for some reason, right? Things like that. So it's a big challenge. It's a big concern. All of the major cloud vendors have this type of framework for people to work with. There's been some collaboration amongst, Google, Amazon, IBM, Microsoft, right, to have some set of standards around this. But again, it's more of a consortium than it is a law per se, right?
Right, and this is one part of the bias that is well covered as you explained. But I was thinking more in the bias in unconscious bias that we have when you have data. So, for example, in the Picasso example, Picasso has different kind of painting. So that the first he used to paint clouds. No, not cloud. The character, the Jokers. Jokers.
Oh,
sorry,
yeah.
Jokers.
Yeah.
And the pictures that you have there are all cubist.
Right.
So if I put a Joker there, maybe it will not classify as Picasso paint.
Possibly.
Yeah. So the point is,
We can try.
any thought in how to create the appropriate set for training?
Yeah.
It's hard, no?
That's a good question. It is because, like you said, I mean, and I'm not familiar with his artwork, right? But I'm assuming that was
Trying
like
to join.
earlier in his career, right? He painted the Jokers, and then later in his career, he transitioned to something else, right? That's a good question around how do you train a model appropriately to make sure it's encompassing everything you need it to. It goes back to the cat example, right? As a human, we're looking at the rear end of a cat. We know it's a cat. We're pretty sure it's a cat, right? But the computer, if it's not trained that way, it's not going to know any better, right? And so, I mean, and I think that's a big focus area for like unintentional bias, right? Just being naive against something like that, right? And yeah, it's a big challenge. How do you know that you're providing enough of details, if you will, examples, if you will, to be able to build an appropriate model? It's a very good question. It's a hard one to address. So yeah.
I don't remember if you remember a few years ago, Microsoft had put some kind of bot.
Oh, yeah.
And the hackers figured out a way and it started saying all sort of.
Yeah, they made it a racist bot within an hour, I believe. Yeah, it was very quick. Yeah.
So even images could be the same, right?
Yeah. Yeah, absolutely. So this is the result that you get when you train your model, right? So we've had all these images in, and essentially now we're showing the accuracy with which we can do our predictions based on the results, right? And so, just when we hover over these, right, the precision number is whether a tag is predicted by the model, how likely it is it's going to be right. So this thing is going to be 100% right. And I think that's because all of the images have a tag and all of the images are tagged as a painting, right? So if it's a painting, it's going to be right 100% of the time. We saw 99.9, right? But now when you start looking at where some of them are tagged as one thing, and then some of them are tagged as something else, then you basically, your precision is going to change, right? Next, we've got our recall. So it'll basically tell you out of the tags, which should be predicted correctly, okay? What percentage did your model correctly find? And so this is more, okay, well, we have, 4 or 5 different tags that we've got here. We know that all of them are tagged as a painting again. So we're definitely going to be right on one of the tags, but then all the other paintings have another tag. And so you're 50-50 on whether or not that'll be accurate. And then finally, your, I forget what AP stands for. Yeah, performance, that's right. Measure the model performance, summarize precision, recall at different thresholds. And so what you can actually do is you can change your probability threshold. And so you got your minimum probability score for prediction to be valid when calculating precision and recall. So now if we increase our probability, 5%, say, other numbers are supposed to change. They did not change. Why not? Normally you'd see these change. I'm not sure what's wrong. Anyways, so now your recall is lower. I don't know why that didn't change though. Anyway, and then let's see, we've got our prediction URL, which is basically that endpoint, that API that you can call to call against your prediction, essentially.
How did you go there on the top, prediction API?
Prediction URL. Yep. And then when we go, yes, sir.
What's happened with the image after the model evaluate? For example,
Sorry, I didn't catch that.
what's happened with the image after you submit it to API, models runs, evaluate, what happened? This one is a store, is
You can determine what it does. It'll stay in cache for a little while. It'll eventually get cleared out of cache unless you tell it to go somewhere else. So because you're storing it in a model, right? And so then that sits in that, the model will reference that set of images, right? So it'll sit there. But you're talking if we add in a new image?
Yes.
You know, for example, with this cat,
Yep.
you upload to your application,
Yep.
right? It's in your storage.
Yep.
And you send the cat through the API.
Yep.
So the API get the full image.
Yep.
Use it for the evaluation.
Yep.
Give you the scores.
Yep.
Right?
Yep.
What's happened with the image?
So the results of the image get sent to the model. I don't think it actually gets stored in image form. I think the details about the image.
It's a mathematical formula with a big array.
Right.
So the image is gone now.
The image itself doesn't get stored in there.
Okay.
And that will sit in cache. Now, you can do something else with it, right? So if you want to keep it for later, you can send it to a different location if you wanted to.
Yeah, but basically we'd like to know if the services keep the image of the customer, or the image that the people are sending. It looks like not.
In this case, right, these are being stored because we're using them as examples.
Yeah.
Right. But when in the actual model itself, it's all just a mathematical formula, right, for the algorithm that you're building for that ML model, essentially. Yeah. In our case, we processed it and then sent the image to blob storage somewhere else to just store it long term. So we had it. So. What else did I want to show? Here, just some more of the details, right? So when we want to access the cognitive service itself, right, it shows some of the details around it, what your usage is, that type of stuff. Yes, it will. I didn't think it would let you change it. And then, you can set your limits, and that's basically to somewhat control your spend, right? You don't want people to blow up your Azure bill by playing around with some of this stuff. So now I want to go back and I wanted to check the search on the Picasso. Should be a good example, right? So is that what you're referring to?
Right.
Okay. So something tells me that based on this image here, might have a match. Let's see. In fairness, this is a funky angle on this desk. All right. So 77%, right? And again, I think a lot of that is based on sort of just the structure of the painting itself, right? Some of the features of it. But if, you're in person looking at the paintings side by side, there are certain elements or aspects of that painting itself and that distinguishes it a little separately, so. What else? I think that covers the service pretty well. Any other thoughts, questions?
Performance and throttling.
Yeah, so that goes into the tiering a lot. So if we look at the custom vision service as we go to spin it up.
Can you also just show us on the Azure, what services and roughly just an idea to get an idea how bad the bill will be?
Yeah.
Before we test it.
Yeah.
Because we don't have an account like yours, right, from Microsoft.
I had limits on my accounts too, actually. All right, so this is actually only there. So there are different tiers of the standard tier. But you can see for the most part, it's based on number of transactions, compute hour, things like that, right? And so that's kind of the way it gets broken down. Now, it does have a cap of 6 megabyte images. This is something that I found really interesting. The deeper the image, the more sophisticated the image doesn't make it a better image for training. Because if we talk about, you think back to breaking down that image, you want to actually simplify it to be able to pick up the features of it and stuff like that. You don't need that super clear, crisp image, right? So you don't want super high res image. Yes, sir.
When you add additional images for training your model, does it just need to do the training on the new set?
Nope.
Or does it need to do
Retrains the whole set.
That's the advantage of using the Microsoft model, right? Because it's been trained.
Right.
For a.
Yeah, but, in this case, it would, using this example, it would have to be trained on the artwork. The existing Microsoft model would have to be trained on what that artwork is, right? That base Microsoft model is more based on those domains that we're seeing, like food, people, right? You can do, celebrity recognition is one of them. What else? OCR is obviously one. What else is in there? landscapes, scenery, major landmarks, so like it can recognize the Eiffel Tower and stuff like that, right? So that's a pre-trained model, but in this case, I don't think you'd be able to load a Picasso and it'd be able to come back to you and say it was a Picasso. You know what I mean? It's and that's why I demonstrated the custom
Okay,
vision
yeah,
aspect.
I got it.
Yeah. Actually, if I go to the pricing calculator.
So it will create a resource group for you when you start automatically?
Nope, you have to create that yourself. Well, when you think about it, remember it said create your compute, because you can actually just go straight into customvision.ai. And you have the ability to create your compute right there. It'll have you specify
Okay.
a resource group in your Azure tenant or create one.
Got it.
So it's similar to any other resource, existing or new kind of thing. Vision.
And, and this is image storage is for the training set, right?
Yes.
Even for prediction, no?
What do you mean?
Well, when you load the picture up,
Ah, okay.
right, you're predicting against it. Better than the free. I thought there were more. Yeah, and there's some of, oh, that's right, the get thumbnail. So the part of the service will create a thumbnail of your image. I don't really have a great use case of that, to be honest with you. I'm not sure why, describe and recognize text, OCR, is it adult image? Landmark, celebrities, all that. Jason, can you check I don't see the chat.
Yeah.
I thought a question might have popped up.
I just asked if there were any questions.
Oh, okay. Oh, it was you that asked the question.
Yeah.
Okay.
Nobody's,
Everybody's asleep. I put them all to sleep.
they're all.
And we lost Veronica too. I'll have to harass her later.
You can tell them that, hey, I'm raffling out like $10 some credit for Azure.
Actually, now that you mention it, you just reminded me. I brought tchotchkes tonight.
Stickers in my.
What's that?
You need some socks. You don't have any on. You don't have socks on either. You guys need them.
Thank you. Stickers, anyone want stickers? If I use stickers?
So the irony about these socks is that I've had them in my garage for the last 2.5-ish years because of a SQL Saturday we were supposed to have. And it got canceled because of COVID. So I've got these socks sitting in my garage. So I'm trying to get rid of them. Yeah. Oh, yeah. So here's your S1, S2, S3. So these are actually billed at higher rates. So just for comparison's sake.
Wow,
Same.
$3,600. That's a lot.
You want to play around with that?
Well, but remember, that's 5 million images.
Oh, that's 1,000.
Good model.
Yeah.
Oh, yeah, right.
Yeah.
1,000
Yeah.
transactions.
So the S3 is slightly higher than S1 and S2.
Gotcha.
Yeah. So, in the book, and hopefully I'll come back and give some of those away when I get some demo books, for all that kind of stuff. But, I do a pretty deep dive on the service, both the custom model as well as the CAN model, some of the capabilities, some of the options and stuff like that. But, hopefully this hit the mark and, gave you guys kind of a good overview of what the service looks like and stuff. So I appreciate the questions and stuff. So, and it's great to be back in person.
Yeah, absolutely.
So, anything else before we wrap up? No? Okay. All right. Appreciate it. Thanks for pizza.
Yeah, there's more out there too. I just take some.
I actually may bring a couple slices from it.
We've got an empty box.
It's just got a waste. Yeah.
I don't